which take us to the algorithmic part of any machine learning model. So all the machine learning models need to store their data. That means they need to train. So when during the process of training, what happens? So far we have seen only theoretical stuffs. So what happens? How we are going to store the data? That is what we will see in the coming three or maybe almost all the four remaining chapters. Let me share my screen. Is my screen visible? Is my screen visible?
Yes, sir.
Oh, okay. So today we are going to see about regression. Right? Regression is one of the application of machine learning model. If you correctly remember, we saw about that briefly, very briefly in the introduction part also. Classification, then we had regression. All right, these two come under supervised category. Association and clustering, these two come under unsupervised category. So now we will see in this third unit, we will see regression and some algorithms which are useful for doing this regression operations. And specifically, we are going to study about linear regression. So first you must know what is meant by regression. Regression is a statistical method that helps us to analyze and understand the relationship between two or more variables of interest. Right? So you have two variables in one part. Maybe sometimes you can have more variables also in your application. So how do you find the relationship? Supervised learning has target vectors, right? So whenever you have target vectors, it is nothing but, or the principle is nothing but, we are trying to find the relationship between the inputs and the targets, right? So this regression also come under the category of supervised learning, but it is different from classification in the sense that classification says whether it is a cat or a dog, but when you go for regression, we are going to say that or predict the price or predict the age, predict the salary, predict the business trend based on some variables. So it's normally used for prediction applications. For example, predicting the price of a house. If a house is for a sale, what is the price of a house? We can predict that based on the number of rooms. Say, for example, this is an example. Based on the number of rooms. So, number of rooms is one variable and the price of the house is another variable. So, in this application, we have two variables. Then this comes under the category of two variable regression method. Right? Two variable regression method. And remember, in regression, we are not going to have any classification or this or this. We are going to have a numerical value as answer. The price of house may be 12 lakhs, 13 lakhs, 20 lakhs, or whatever it may be. But that is determined based on one variable. So one variable on one side and one variable on the other side. So we say that this is a two variable application. The same house price can be predicted based on the number of rooms, location, and city. Right? So price of house is a variable, number of rooms is a variable, location is a variable, and city is a variable. So this application or this equation or this statistical method has four variables within it. Right? So if your application is simple, you will fall under case number one, or if your application is complex, you can have even 10 variables or 20 variables. It will fall under case number two. In any case, both fall under the category of regression because your output is going to be a number. So how can we categorize these variables, right? So in all the regression algorithms or the methods, you will repeatedly come across this definition, dependent variable, right? So what is dependent variable? This is the variable that we are trying to understand or forecast or predict, right? In other words, When you look at our application, price of the house, that is a dependent variable. That is what we are trying to predict. But why I am calling it as dependent? Because it is dependent on the number of rooms, or maybe location or city or something like that. So when the number of rooms, location and city changes, this variable also going to change. So the price of the house in our example is called as a dependent variable. Then the other one is independent variable. These are factors that influence the analysis or target variable. Target variable is nothing but the price of the house. But these variables, number of rooms, location, and city, they influence the analysis or the value of the variable and provide us with the information regarding the relationship of the variables. So when these changes, the price of the house also will change, right? Or otherwise, you can think about an equation. You can think about a thing, something like a one-dimensional or 2D equation, right? Where we say that x is equal to, say, for example, 3y. Right? X is equal to 3y, or y is equal to 3x. We can take x as input. Y is equal to 3x. So when the value of x changes, it is multiplied by 3, and your y also is going to change. So y here is the price of the house, and x is nothing but the number of rooms. If you want to have more variables, then it will be y is equal to 3x plus 4z plus something like that. So depending upon the number of variables, you are going to have an output. I hope this is very clear to you. So these dependent variables and independent variables are going to play a crucial role in the regression process. So there are many types of regressions. So this is normal regression. What is regression? Simple mathematical calculation. But these regression techniques are of many types, which are different based on the number of independent variables. What do you mean by independent variable? The number of rooms, location, city, and so many things. So if that becomes more, or that if that increases, then we are going to call regression as one type, or otherwise we are going to call regression as another type. And the type of relationship between the independent and the dependent variables. How does we have a relationship between the independent and the dependent variables? So based on these things, we are going to classify our regression into many types. Right? So regression models, if you have just two variables, when I say two variables, one dependent variable and one independent variable, then it is called as simple regression model. Right? Or if you have more than two independent or more than one independent variable, then we are going to call it as multiple regression model. So when you have an application, based on the data you have, you can easily understand whether it is a simple model or a multiple model. So when you look at this specific point, it is classified based on the number of independent variables as simple or multiple. The second one is, in simple model, if you have two variables, again we have a classification called as linear and non-linear. This is the type of relationship between the inputs and the targets. Right? In the same way, when you go for multiple models also, we have the linear and the non-linear. That's why we say that it is also classified based on the type of relationship between the independent and dependent variables. Your y is the target, your x is the input. So when I say relationship between independent and dependent, it is actually the relationship between the inputs and the targets. So numbers, it will be easy for you, simple and multiple, but you must understand what is meant by linear and non-linear, because the topic which we are going to learn is all about linear regression. So I'm just showing you a graph here. You have a two-dimensional space where x is in the x-axis and t is in the y-axis, right? So now when you have a two-dimensional point, you will have a coordinate. So you have many set of points, all the blue color circles, 1, 2, 3, 4, 5, 6, 7, 8, 10 blue color circles are there. So each circle corresponds to a coordinate. That means an x point and a t point. Likewise, you have 10 sets. This is your training data. This is your training data, right? Now, when I go for training the model with this data, the model corresponds to the hypothesis corresponds to the green color or the red color. I have two models here. If I go for the green color model, it says the shape is non-linear. What do you mean by non-linear? Suddenly it will increase, suddenly it will fall. You cannot predict. It is very, very difficult to predict. You cannot say it is falling, so it is going to keep on falling. No, it again may start increase. Fluctuations, right? So all the fluctuations comes under the category of non-linearity. But the beauty is the non-linearity. If you look at the green color curve, it touches most of the blue color dots. It touches most of the blue color dots, right? Say for example, 1, 2, 3, 4, 4 dots it is able to touch. So the accuracy or the fitting process, right, is very accurate, because you can go rise and fall. If the training data increases, you can increase. If the training data falls, you can fall, and you can have a very good training model, right? So the touching of green colors with the blue color shows that it is a perfect trained model. But when you come to the next one, red color, you can see that only one blue color dot is touched by this hypothesis or model, right? That means the error rate of this red color line is more than your green color line. And this red color line is called as a linear model. That means when it is going to fall down, it will keep on falling. Or when it climbs, it will keep on climbing. There will be a very steady or easy to identify pattern. 1, 1, 2, 2, 3, 3, 4, 4. All these things come under the category of linearity. Right? So it is very simple. The advantage is linear hypothesis or models are very simple, but the accuracy is not that much in comparison to a non-linear model, where non-linear models are much more complex. Right? So this graph you must always understand to know the difference between linearity and the non-linearity. But in our syllabus or in our case, because you are very new to the machine learning subjects, we are going to concentrate only on the linear regression models, right? The algorithms which are able to fit the training data using only a line. Why I am saying a line? The lines are linear in nature. All other shapes are going to be non-linear. Triangle, square, rectangle, everything is going to fall and have different shapes, right? They are going to be non-linear. But you have to pay for the accuracy. You cannot expect much accuracy. So if your application is simple, we can go for linear regression, right? That's why we have a classification like this based on the number of variables. Here in our graph, I have given you two variables, right? One input and one output. The same way, you can have a multi-dimensional space also. You can have many inputs and one output also is possible. And in the same way, you can have the linear and so we are going to concentrate only on linear regression models. So simple linear regression. Simple means two variables and linear. The normal line is useful for finding the relationship between two continuous variables. So always remember, classification means discrete, right? Never ever forget that. It is a cat or a dog, over. But when you go for your regression process, all the variables, it's like an equation where x will have a set of values and y will have a set of values. You can have a graph, you can have a line or anything like that. But in classification, you cannot have a graph. You have to say that 80% or 20% accuracy. So regression is always continuous. Your classification is always discrete. And we have other names for the independent variable. I'm giving you this because when you refer textbooks or any online sources, you may have different names, right? Predictor. Predictor is also called as independent variable. And the other one is response or dependent variable. One is the output and one is the input. It looks for statistical relationship, but not deterministic relationship, right? So these are some words which a machine learning engineer should know. What do you mean by statistics? What do you mean by deterministic and everything, right? Only then when you read any line, the problem with us engineering and the way in which we study engineering is when you come to the final year and read some concepts, you do not understand. You say do not understand. Why you are not able to understand? Because the words which are used there is not known to you. Why it is not known to you? Because You have not gone into depth on those words. Right? Otherwise, an engineer can read all the technical words and they can easily understand it. So machine learning is all about statistics and deterministic. So let us see what relationship they are talking about. So relationship between two variables is said to be deterministic if one variable can be accurately expressed by the other. Right? Deterministic means accuracy. Say, for example, temperature in degrees Celsius, it is possible to accurately predict in Fahrenheit. No other values will be there. If it is 33 degrees Celsius, it may be 90 degree Fahrenheit. Right? So when you have a degree Celsius and a Fahrenheit chart, you can easily go for finding the relationship. That means if the degree Celsius increases by 2, definitely your Fahrenheit also should increase by 2. Right? So these type of applications where there is a clear-cut relationship, we call it as deterministic relationship. But there are some other relationship, right? Maybe between the height and the weight. If I am 5 feet 10 inches height, right? My weight need not be something relevant to that. Maybe I am underweight, or another person who is having the same weight may be overweight. Right? So you cannot say the height is 5 feet, so the weight should be 40 kg or something like that. We have a BMI which determines the index, but practically nobody need to follow that. So if you go for such applications, we call it as a statistical relationship. So when you look at your linear regression, we say that it is always looking for statistical relationship. That means it is not going to be highly accurate. It is not going to be highly accurate. Why do I say that? When we train the model, when the line is trying to touch all the blue circles, rarely it is going to touch all the blue circles. Right? Definitely there will be some difference between the data. Because why does it happen? Because the data itself is complex. Your Fahrenheit and temperature Celsius data is very easy. Right? Anybody can say. But when you go for height and weight, the data itself is complex. So your model also may not be able to perfectly match with your training data. That is where we need machine learning. We need not have machine learning for deterministic, because just by mathematical calculation, you can find out. But only if there is a statistical relationship, we need machine learning. So our all models are going to measure these relationship. So now we will slowly shift into the mathematical part of our stuff. So this linear regression, you can assume as an equation, right? Don't get tensed when you look at mathematical equation. It's a very easy one. Right? Y. What is y? Can anyone tell me what is y? Which variable? Dependent or independent? Can you tell me?
Dependent.
Y is independent or dependent variable? Okay. You can even read the contents below that line and tell me, right?
Dependent.
Yeah, y is a very good part. Y is a dependent variable because when the x value changes, which is on the other side of the equation, when the x value changes, my y value also going to change. So I can represent my linear equation like y is equal to a naught plus a1x. Have you ever come across this equation earlier in your first year or your school? Anytime, can you tell me a analogous equation for this?
Y is equal to mx plus b.
Exactly. Thank you very much. Can I know your name?
Angel Rajam.
Angel Rajam. Thank you. Very good. That's an excellent answer. Y is equal to mx plus c. So logically, I'm saying a naught plus a1x, but you can also say that a line, a linear regression model or hypothesis is always represented by a line. Always represented by a line, right? Y is equal to mx plus c. Here, instead of m and c, I have given y is equal to a naught plus a1x. So only two variables. Don't think we have many variables. Only two variables. What are they? Y and x. One is the dependent variable and other one is the independent variable. But other than that, we have two parameters there. We can say parameters or we can say constants. Now the duty of the machine learning algorithm is what should be the value of A0 and A1 to make sure that X and Y will have a linear relationship. If I can pinpoint the A0, A1 value and I can fix it for all value of X, I am going to get a correct value of Y. So when I give it to a new value, the testing process, when I give my method or model to a new data of X, it is going to predict Y. So that is the idea of this complete linear regression model, right? So A0 and A1, I have many times I have thought, what is it Y is equal to mx plus C? What is that plus C? Why don't we make C is equal to 0? Y is equal to mx, that should be fine, right? But there are interesting reasons why we have that C and what is this M is all about, right? In our example, in a equation, I have given as A0 and A1. So A0, first we will see about A1, right? A1 is the linear regression coefficient, or it is called a slope of the line, right? M corresponds to the slope of the line. Y is equal to mx plus C. Here M is replaced with A1. Right? M is replaced with A1. And A0, what is A0? It is called as the intercept of the line. Intercept of the line. What is this intercept? Just read the last line in the slide. It is the value of Y when X is equal to 0. The starting point of the red color line. Right? The value of Y is in the vertical axis. What is the value of Y in that line when X is equal to 0? That is called as A0. And A1 is nothing but the slope, which can change its angle. When the slope changes, the angle also will change. Right? So we have Y is equal to mx is fine, but the A0, whether we should have A0 or not, we will look at these things in the subsequent slides. Now, I hope you will understand this. Look at the graph below. You have an x-axis, you have an y-axis, and you have a hypothesis or a model, the best fit model we can say, but not sure how best it will be. That means it is going to touch all the blue data or the training data. So slope B1, I think it is A1 in our equation, but in the diagram it is given as beta 1. Both are same. Beta 1, A1, M, both all are same. Right? It denotes the slope, and the starting point here it is called as B0, but in the equation I have given as A0. Right? So this any machine learning model which is used for linear regression should have this. Right? Now the question is, this is a simple regression model. We have one dependent variable and one independent variable. If suppose I have multiple linear regression models, then what will happen? A0 will remain the same, right? Plus A1x plus I can have A2y, A2z. Z can be another variable. Likewise, each variable can have a weights A1, A2, A3, A4, A5, and then we can have an output. Right? Remember, if you do not have A1 and A0, what will happen? It will be just like Y is equal to X. Then that means there is no relation. Only that A1 gives some weightage. If it is 0.5 or 3, accordingly, the X value changes, and we are going to capture the relationship with Y. So that M and C, A0 and A1 are very, very important. So the main idea is, what should be the line? Where should be the line? To make sure it touches all my training data. It is also called as curve fitting. Curve fitting in mathematics, if any of your relatives are with statistics or mathematics, they will be talking much about curve fitting. Right? A model which can touch all the training data so that when I go for a testing data, it will predict the correct answer. Right? So when can we get the correct line? When we can get the correct line? The logic says when all the points are touched. So when you touch all the points, it indicates the error at that point is 0. The error at that point is 0. What is the formula for error? Here we say that this Y. Y is the predicted output from your method or your machine learning model. Already we have a predetermined Y. So the method is going to give you one Y, and already we have a target Y, whether both are matching. Right? If both are matching, then your error is going to be 0. If not, your error is not equal to 0. So you need to, that's why the green color dot, when it touches all the points at all 10 instances, the training data is going to exactly match. In other sense, your predicted output and your target, which you already have, is going to be same. We can have a small example. We have a data set which contains information about relationship between number of hours studied by a student and marks obtained. Right? Number of hours studied and marks obtained. Again, you should remember this is a statistical relationship. Right? We cannot say when a student study for more hour, he is going to get the marks, get 100 marks. There is no specific relationship, no deterministic relationship. Only for such applications, we should go for linear regression models. So many students have been observed and there was some study. Maybe I can come to your hostels and take a note of how much time you learn and how much grade you have got. That all those things will be recorded. That will be our training data. And now goal is to design a model that can predict marks if given the number of hours studied. Right? It will be very useful for students if you can find something like that. Okay, if you study 5 hours for machine learning, you are going to get 70 marks. How interesting it will be. You can again sleep after the 5th hour. Or if you study for 1 hour, you are going to have 30 marks or 40 marks. Then you will know how much time you should study. That is the interesting aspect of machine learning models. So using this training data, a regression line. Remember, we are studying about linear regression. So I will be talking only about a line. If it is non-linear or anything, some other shape may be there. A regression line is obtained, which will give minimum error. That means when I go for testing, I should get a correct answer. I cannot have random answer when I go for testing. 5 hours, if I study, 50 marks. If that is the case, when I go for testing also, then that is fine. That means my predicted output, the tested output, and my already the experimental data, both are going to match. If they are matching, then the error is going to be 0. Not only for one student, it should be for all the students. If I have 10 blue color circles, my line should touch all the 10 blue color circles. But practically, it is very, very difficult. Even when you are drawing a graph in your electronics experiment or in your LIC experiment, right? You may get some characteristic curves. Maybe the forward characteristics of, I forgot those. Forward characteristics of diode or something like that. When you try to draw a curve, right? You may get many points. But how will you draw? You will not try to have some irregular waveform. Your thing is you need a curve, so you will miss out on some points. That is what we are studying now, right? Regression or curve fitting. But if it touches everything, then it is perfect. If not, some data has been wrongly mismatched or many reasons may be there why we do not get a perfect output. So if we give the number of hours studied by a student as an input, x is equal to the number of hours studied by a student, my model y should predict their mark with minimum error. I cannot say error can be equal to 0, but minimum error, tolerable error. If that is the case, then it is fine. So now the question is, what should be the value of B0 and B1? I do not know B0 and B1. If I know B0 and B1 well in advance, I will just substitute in my equation, and for each x, I will get an y. Right? So who will tell me what is B0 and B1? My machine learning algorithms. There are so many algorithms for regression which are able to estimate this B0 and B1 given as a standard set of x and y values. If you closely observe the equation, B1 is based on your x, your input, and y. So initially B0 and B1 will be always randomly assigned. Once you have a random B0 and B1 values, it will be easy to find y. If you have x and y, a new value of B1 will be found. If a new value of B1 is found, we can have a B0 value. Again, with this B0 value, again we go for changing your x and y. And this will be an iterative process where you will get B0 and B. Right? So this is what we are going to see in the subsequent classes, how we are going to find out B0 and B1, or in our expression A0 and A1. And this is the formula for error. My system is going to give an output, which I'm going to call it as predicted output. And already I know this is the output for this stuff, right? That will be an actual output. So if both matches, when I say matching, it is nothing but the subtraction operation. I go for taking the mean square error for this. So I go for the squaring of these values. And then if it is 0, then everything is 0. If not, I will get some. Why do I go for squaring? Any idea? Why should we go for only error? Why should we go for mean square error? Any idea? Subtraction, right? Subtraction, always the first number should be larger, second number should be smaller. But sometimes there may be a case when I get an output a larger value, predicted output as larger value. Then I will face some negative sign, which when error is calculated, it may affect the other person's error value also. That's why to avoid that, we go for always that squaring concept. Now we will see something about B1 and B0, right? What is B1 or A1? It is the slope. So if the value of the slope is greater than 0, then your x and y will have a positive relationship. Remember that equation. Y is equal to B0 plus B1x or A0 plus A1x. So if that value is having a, if that slope is having a value greater than 0, then you will have a positive relationship. I am showing the diagram also for positive relationship. Right? Don't get confused with A1 and B1. All that one corresponds to the slope. That means your x is going to increase. That's what I told you. If your graph is going to increase, it is not going to fall because it is linear. It is going to always only increase. But how much is the increase? That will be interesting to find out. The same way, when you go for the negative value, that means when the slope value is less than 0, we are going to have in a reverse direction or in a negative direction. So the shape of the graph will change. That means your x will increase with a decrease in y, or your y will increase with a decrease in y, opposite to f. This is all about your B1. So this B1 is very, very important to determine the relationship between x and y. If B is equal to 1, if B1 is equal to 1, what will happen? If B1 is equal to 1 or A1 is equal to 1, what will happen? Right? There will not be any meaning in going for the machine learning model because y is equal to A0 plus x. What is there in that? Y is equal to x. Nothing special in that. So always make sure you have some weightage with x, which determines the relationship between x. Now the next question is, why should we have B0? Y is equal to mx plus c. What is the necessity for c? We will just remove that. If you do not have this B0, which is called as intercept. What is intercept? The value of y when x is equal to 0. So we can justify this with the help of an example. For example, you have a data set that relates height and weight. Height is x and weight is y. Say, for example, first you take x is equal to 0. Right? X is equal to 0. That means height is 0. Say, for example, some person is lying down. Right? Some person is lying down on the floor and you are measuring the height vertically. Maybe very, very negligible one. You can take it as 0. It is not the actual height of the person. You are measuring the height vertically. Maybe some applications are there. Your x is equal to 0. Right? Now, if you go for our equation says, look at the first equation. Our equation says y is equal to B0 plus B1x. Suppose you assume that you do not have B0 and no necessity for intercept. Now, when you substitute x is equal to 0, B1 into x is B1 into 0 is 0. So x is equal to 0, y also will become 0. But practically speaking, the person who is lying down, if you take a height and weight application, if his height is 0, when you are measuring vertically, your weight should be there. Your y cannot be equal to 0, which is completely meaningless because in real time, height and weight can never be equal to 0. This is not applicable for all the applications. Right? For some applications, we need that B0. If you do not have, so if you have some value for B0, 0 plus something is some kgs or something like that, you will get. That's why B0 is very, very important. Y is equal to mx plus c. That constant is very, very important. If the model includes value of 0, right? So we know that now B0 is very, very important. If we include a B0, then what is the value? Easy way to find out is it is the average of all predicted values, that y values, right? When x is equal to 0. So in this graph, you can see, take the first graph, or you can take the second graph, right? The starting point, or I can show you a better one. Yeah, here you can see So the B naught value is normally, most of the time, 90%, it is going to be the average of the values in your y-axis. Depending upon the scale you have, your position will vary. It is actually the average. Right? So this is all about linear regression. Now our duty is how you are going to find these values of B naught and B1. Machine learning model should have a correct B naught and B1 value so that the fitting will be perfect, or the prediction or the testing process is going to be 100% perfect. So with these introductory concepts of regression, we will go into many algorithms to look at the process of regression. So where we are using regression, it is in finance industry, understand the trends in the stock prices, forecasting the prices, marketing, effective market campaigns, forecasting the prices and sales. Whenever money is involved, right? Money is involved, we normally go into regression. Manufacturing, the relationship of variables that determine for a better engine, maybe the pressure, the mechanical stuffs can come into play here. Medicine, what a combination of medicines should I give to make sure that this genetic disease or something will go off, something. So we'll upload these things. Please go through that, because based on these concepts, we are going to have our algorithms later. So it is very, very important to understand these things in the best possible. If you're unable to understand any mathematical concept or any specific stuff or anything of that sort, please let me know. Remember, machine learning is highly debatable. Right? Most of the concepts are still under research. So we say that 95% it is going to be there, but 5% you can also say why it can't be there. Right? We can go for some new innovation or something different also. So for that, you need to have a good understanding. What is A, B, C, everything you need to know. Let me mark the attendance. Amulya?
Yes, sir.
Judson? Judson?
Yes, sir.
So please give a prompt attendance so that we need not waste time. Samyukta?
Present, sir.
Angel?
Present, sir.
Ajit Pawar?
Present, sir.
Abhinaya?
Yes, sir.
Kiran Kumar?
Present, sir.
Manideep? Manideep?
He has put it in the chat box, sir.
Given in chat box. Bhanuteja?
Chat box.
Okay. Jennifer?
Yes, sir.
Priyadarshini? Priyadarshini? Priyadarshini absent?
Yes, sir.
Priyadarshini present?
Yes, sir.
Jeevan?
Sir.
Okay, okay. Jeevan? Jeevan. Yeah, okay. Afreed?
Present, sir.
Jayant?
Yes, sir.
Jayant?
Present, sir.
Okay. Vikas?
Present, sir.
Paulfini?
Present, sir.
Bhuneshwar?
Present, sir.
Sumant Kumar?
Present, sir.
Ramesh Kumar?
Present, sir.
Neeraj Kumar?
Yes, sir.
Zubair? Zubair? Okay. See, the timing is not good for a machine learning class, right? Exactly. All of us feel hungry. Even I am feeling hungry. But let us, that's the way how we, the timetable is scheduled. We need to manage with that. And mathematical concepts are also very important for machine learning. You cannot miss out on that. So I request you to pay some attention on that. Kirti?
Yes, sir.
Dinesh?
Yes, sir.
Tejaswant?
Yes, sir.
Chandana Priya?
Present, sir.
Karthik?
Yes, sir.
Vijay Kumar?
Yes, sir.
Soman,
Yes, sir.
Ganesh,
Present, sir.
Vimal,
Yes, sir.
Harshavardhan,
Yes, sir.
Uday,
Yes, sir.
Sakib,
Yes, sir.
Siddharth,
Yes, sir.
Salomi,
Yes, sir.
Praneeth,
Yes, sir.
Livingston,
Yes, sir.
Alan,
Yes, sir.
Ronan,
Yes, sir.
Taikiran,
Yes, sir.
Yoshiba,
Yes, sir.
Shiny,
Yes, sir.
Jasmine,
Yes, sir.
Kavya,
Yes, sir.
Jayasurya,
Yes, sir.
Joanna Paul,
Yes, sir.
Manasa,
Yes, sir.
Ashrita, Ashrita,
Chat box, sir.
Chat box, sir.
okay. Narasimha Reddy,
Yes, sir. Yes, sir.
Puneet Kumar, Shiny, Shiny, Shiny absent,
Yes, sir. Present, sir.
Joshua, Shiny presenter, Shiny,
Present, sir.
Shiny absent or present?
Present, sir.
Okay, your voice is not audible. Joshua, Nagakiran,
Chat box, sir.
okay. Suraj, chat box.
Chat box, sir.
Okay. You missed somewhere. Suraj. Yeah, Maunika,
Yes, sir.
Taufik,
Yes, sir.
Manideep,
Present, sir.
Dikshit,
Yes, sir.
Maria Angel. I think Maria Angel has typed her
box.
name.
Chat box.
Chat
I
box.
saw that. I saw that. I think she has kept everything ready. So whenever I call her name, she press enter, I think. Perfect. Amrut,
Yes, sir.
Pavan Kalyan,
Yes, sir.
Ainath,
Sir.
Gautam,
Yes, sir.
Jagat Chandra,
Present, sir.
Vivekananda,
Yes, sir.
Ashan,
Yes, sir.
Sai Ganesh,
Yes, sir.
Gopichand,
Yes, sir.
Ritvik, Ritvik, chat box. Ritvik, absent. Solomon,
Present, sir.
Sir, present,
Sudarshan,
sir, Ritvik.
Sir, Ritik present, sir. My mic was not working there.
okay. Sudarshan,
Yes, sir. Present, sir.
Sujit Kumar,
Present, sir.
Suresh Kumar,
Yes, sir.
Sunny, Sunny absent.
Present, sir.
Amrita Das.
Present, sir.
Okay, so all present today. See, these concepts which we have learned today, if you look at the first sight, it will not be impressive to you, right? You need to read that again and again and again. That is the trick behind learning machine learning, right? So I will upload that in the Google Classroom. Whenever you find some leisure time, I'm not asking you to keep on learning them. Whenever you find leisure time, please go through, right? You read each and line and try to know the meaning of each word. That is very, very important. Only then you can understand the complete concept. Thank you, students. You can leave the G Meet.